Hello, my name is Chris Hopkinson. I'm a professor of geography and environment. I have two appointments, one adjunct at the University of Lethbridge and one professor at the Western University in Ontario. Today we're going to learn a little bit about the Westcastle Field Station here in the headwaters of the Oldman Basin in the Canadian Rocky Mountains. You can see the field station behind me. And we're going to talk a little bit about our digital twin project, which involves Neospatial, a company that works with Unreal Game Engine, and also Inside Education, a company that delivers solutions for classroom education. Over the next few minutes we will look at the weather station at the Westcastle Field Station, some of the sensors that we're using to control the environment settings within the digital twin. Before we wander over to the weather station, however, I'll just briefly explain some of the steps that Neospatial, which would be James Graham, Alex and Caleb, have had to go through to put the digital twin together. We are fortunate because here at the Westcastle Field Station and the surrounding watershed, my lab has been collecting airborne lidar and airborne photographic data since 2014. So we have a very rich and high-resolution data set describing the terrain and the land covers. So these data have been used by Neospatial to generate the mesh or the terrain upon which all of the assets within the game engine can be placed. So once the terrain is created, they then add the trees and other vegetation land covers, and then build a number of assets or three-dimensional buildings and weather station features that are also added into the game engine. Now, what you'll see throughout the rest of the presentation is that while we're describing the weather station and some other elements of the project, we'll pull a few screen grabs and video snips just to illustrate what this looks like.
Hi, my name is Celeste Barnes, and I'm affiliated with both the University of Lethbridge and Western University. I'm a postdoctoral fellow, and I am studying the snow and the snow in the mountains. So in that radiation shield, we also have air temperature, which monitors the temperature of the air. We also have a temperature sensor on the ground so that we can actually see what the difference is in temperature in the atmosphere and at the ground. The sensor at the end of the arm, the round black one, is an SR50, and this measures snow depth. And so as the snow falls, we can actually see how much, how deep the snow is, and then as it's melting, we can actually see the snow depth go down.
Hi, my name is Laura Chasmer. I'm an associate professor in the Department of Geography and Environment at the University of Western Ontario. My research looks into the impacts of wildfire on vegetation and vice versa. The anemometer at the top of the tower measures wind speed and direction, and this is important for us to understand snow distribution, but also the directionality of wildfire. In the white radiation shield in the middle of the tower is atmospheric humidity. And atmospheric humidity tells us about the moisture in the atmosphere and near the ground surface. Adjacent to relative humidity, in the logger box, we have an air pressure sensor. The air pressure sensor can tell us the high and low pressure of the atmosphere, which gives us an indication of whether the atmosphere is going to result in clear conditions or cloudy and rainy conditions.
Behind me on the tower, you can see these white enclosures. Each one of these has something to control the power or the flow of data from the sensors, ultimately back out to the web. And so this really is the guts of the information component of our weather station. So the sensor I'm pointing to here on the boom that kind of is pointing towards me, that is a total radiation or net radiation sensor. So we have incoming from the sky and outgoing from the ground, shortwave and long wave radiation. And so those two types of radiation are basically the radiation that comes from the sun, shortwave, and then the long wave radiation is the radiation emitted from the earth or the trees or the clouds or everything around us. Here we have the GeoNOR total precipitation gauge. This measures both the total snowpack and rainfall, and we keep this going all year round. Very, very important, one of our sensors, and you can also see it in the digital twin. So the forest around the Westcastle Field Station is dominated by conifers, but immediately behind me you'll see a small stand of aspen trees. One thing we've tried to do in the Westcastle Digital Twin is to recreate the seasonal variations in the landscape. And of course, one of the important characteristics of seasonality, other than snow and green grass, of course, is that the deciduous trees bud and then leaf out, and then during the winter, of course, they have no leaves at all. Now you can see here we are right now in the middle of May, and the trees have just started to bud. So behind me you can see the Westcastle Creek, which is about 100 meters or so away from the field station. And even further behind me you might be able to see the mountains and the forests that trail on for many kilometers, 20 to 30 kilometers upstream. And the entire area around me, like either side, behind, in front, this is known as the Westcastle watershed, which is a headwater in the Old Man River Basin, and of course one of the very important ones. As you've seen, we have a couple of weather stations where we monitor some of the key hydrometeorological variables. But also the government of Alberta has two stations not too far from here, one in the valley and one a little bit higher up. And so this is a very important area in the Old Man for monitoring hydrology, snowpack, water resources in general. And so that's part of what our research here is all about. It's about understanding the processes, the environmental physics, and how all of these data streams work together. And so one of the cool things that we're trying to do with the digital twin is to bring all of that information about this very important headwater environment out into the public domain, and use the actual data that we're collecting to control the environment in the digital twin, in the Unreal game engine. And so it won't be exactly photorealistic, but it's as close as we can get, in the sense that it's like a video camera that you can enter into and move around. So that's kind of our goal, and I think we're very close to implementing that now. So what do you think is cool about this project?
So one of the things I think is really cool about this is, as scientists, we always just look at all of the information, all the data on graphs and plots, and it's, you know, a little bit hard to read. And so for the younger generation who's very familiar working with playing it with games, you can actually get right in and see how that data is represented in the real world.
I think this project is incredibly exciting because it gives us an opportunity to wander through the forests as they're changing with the weather conditions. It also gives us an opportunity to better understand the hazards that impact our communities, such as wildfire. So through the digital twin, we can see how smoke is impacting communities, and potentially, perhaps in the future, how wildfire can move through these forests and burn them up with the weather conditions that we are monitoring.